In order to fully understand variables, we need to understand something about the process environment. Variables, generally speaking, are data items stored in process memory that are only accessible to the process using them. There is, however, a way to use environment variables to allow the transfer of information from one process to a child process. The transfer is a copy. The child process does not have access to the original variables or the original process's memory, but you can use this to transfer things between them. Bash is like any other process. There's program code and initial data stored in the file /bin/bash, and that code is loaded into memory when we run the bash shell. The process of loading code and data into memory from a file to run is known as creating a process. It allocates memory space, CPU resources, etc., and keeps its own data. That process has a thread of control. A thread of control is simply the CPU advancing through the code. When it reaches the end of the code and the process exits, the program ends. All of its resources are freed. The RAM is given back to the system to use, and all of the data it was working with is now lost. So local data kept in a process stays local to the process, even after it ends. Bash is single-threaded. It does things in sequence. So it executes the first command, then the next command, then the next command. It does not have the ability to be executing two commands at once, although you can start a command in the background and tell Bash not to pay attention to that command anymore and instead come back immediately to work on something else while the first command finishes. This is not multi-threading. This is simply starting multiple processes. Processes are created in Linux, as they are in many operating systems, through a mechanism known as forking. Forking is a mechanism where a program can ask the operating system to make a complete copy or clone of itself. When it does this, the process that's doing the fork will resume after the fork and continue on with whatever task it was doing. It is given the child or new process's ID by the operating system, and the parent process, the originator, can keep track of the child. It also can actually send signals to the child to tell it things like quit. It'll also be notified by the operating system when the child process exits, whether it's a normal exit or an abnormal one. Since the new process, the child process, is a clone, it actually starts out with a copy of everything that the parent process had. However, the normal reason for starting a new process is to execute code other than the code that is in our current process. For example, at the bash command line, we might type the command ls. Bash needs to create a new process for that because the ls command is actually a different program from bash. It lives in the file /bin/ls, and that code has to be loaded. So right after the fork, even though the parent process will simply resume and keep going, the child process will immediately execute or exec the ls program code. That means the operating system is told to write the code from ls into that process, that child process's memory. It brings in the initial data that comes with the ls program. And the only thing that's still left around from the parent is a copy of the environment. Programs can modify the environment. They can remove things from it, add things to it, change things in it. Most programs add some environment variables or content. But variables that we create in the bash shell, and then we run another program, those variables get copied in the environment to the new process. And the new process, if it knows to look for those variables, can retrieve whatever data the parent program intended to copy over to the child process. It's a simple mechanism for moving data between programs. Typically, we use this to set configuration or to modify how the child process will run. In other words, to give it some kind of settings. Creating environment variables is done the same way we create regular variables. We say variable name, equal sign, and some data to put in, some token. When we create a variable, it's created in local memory, which means normally when we fork, that data does not end up in the new program that the child process executes. If we want it to stick around, we have to move it to the environment from local memory. And that's done with the export command. Export and a variable name will move that variable into the environment. It doesn't change what's in it. It simply makes it available to the environment. That way, when we start a child process, that child process gets a copy of this variable. We normally name the environment variables that we intend to use in the environment with all capital letters. It makes them easy to spot. Bash actually doesn't care what you call them, neither does the operating system. But the convention is to use all capitals for environment variable names and all lowercase for local variable names, or in some situations, mixed case for local variable names. We can actually take a variable out of the environment by doing export-n and the variable name. We would only do that if we had something in our environment that we did not want a child process to receive. Since creating environment variables for use in a child process is typically done specifically for that purpose and not for any other, there is a short form of creating the variable, putting data in it, and exporting it all at once. It's the second example on the slide where we say export space some variable name equals whatever data is going in it. The variable gets created, the data gets placed in it, and it gets moved to the environment right away. There is a lab exercise to do called Check My Var. The Check My Var program is a script that you download, and it allows you to see the content of a variable. And the lab exercise walks you through creating the variable, exporting the variable, all the time running the script so you can see what does or does not get transferred to a child process. This works for us because when we run scripts, each script runs in a new process, a new bash process. Try the lab now.